Hello and welcome everyone. My name is Kelly here with Esri and I'd like to welcome you to our webinar today, using GIS to capture and manage structured observations from imagery. Before we get started, I just want to go over a few items. This webinar is being recorded and you will receive a follow-up email with a link to the recording location once it's made available. You are encouraged to post your questions at any point during our demos and presentation today. You can type them into the question or chat box in your GoToWebinar control panel, and our presenters will be collecting these and addressing them at the end in a Q&A session. And with that, I'll go ahead and turn it over to our first presenter today, Ben Conklin.
Thank you for that, Kelly. So thank you for joining us for the National Government Webinar Series. Today we're going to talk about using GIS to capture and manage structured observations from imagery. We have a team here today to talk to you about this topic. I'm Ben Conklin. I'm Director for Defense and Intel Solutions within Esri, and I'm joined by Kurt, Chris Lee, and Kyle Talbot, who are going to take us through the capabilities across ArcGIS for helping us manage structured observations from imagery. Some of you are probably familiar with this, but you don't have to be. We're going to take you through what structured observation management is and how it supports sharing information. It helps us normalize, capture, and record observations from sensors and sources. In general, when we're talking about these observations, we're referring to activities, events, or locations at a point in time. We obtain them from imagery, intelligence reports, or other means from an analyst. Capturing structured observations helps support many different workflows, like automated analysis and pattern detection using tools like artificial intelligence. It helps us maintain situational awareness using structured reporting, and it can support workflows like object-based production. Key takeaways from the session are that you're going to learn how to use ArcGIS as a management system. It will help show you how to establish a web-based workflow for locating, identifying, and capturing observations, and also how to configure your enterprise to create services that can support these workflows, as well as how to share metrics with stakeholders. To provide some context, just needed to look around our world as we see it today. Our security is increasingly challenged. I don't have to tell you this. Many of you, of course, are probably attending this webinar from home because of the global pandemic, but or maybe you had to hurry up and get out of the way of the hurricanes that we're facing or the fires that we're facing. With the world changing everywhere, we see many threats and many challenges, and this is continuing to cause us to need to work together to respond to these. What we could also say about this is the pace of change itself is actually accelerating. So it's creating many challenges, which threatens our security and society. And we're in this new normal of constant change, and we need to improve our understanding, collaboration, and action in order to respond to it. I like to think of this in the context of how intelligence has changed over time as well. So some of you in this call may be part of the intelligence community, others may not, but much of what we're going to talk about supports these changes. And some of them might be to do with military intelligence, and others might do with national strategic intelligence, and some might be in corporations or companies as well. In the early days of intelligence, we really focused around humans in the field collecting data and around single threats. And over time, we've evolved to this technical collection capability and to respond to the threats on our homeland, and using new capabilities like UAVs and web-based tools. And now I'd say we're in this fourth age of intelligence, and we're facing this rise of peer or near-peer threats, and continuing to focus and face threats from both domestic and global terrorism. What's really necessitating is this multi-intelligence integration, and also the need to address across multiple domains like land, air, sea, space, and cyber, and bringing all those together in our response. And we're leveraging new technologies like AI and other tools to help us automate. And what's clear to us is this increasing rate of change is continuing even in this community. And what we're seeing is this need for this digital transformation of intelligence. And I just say need, we also see it happening in many organizations as they re-envision their workflows. And in many cases, what's happening is we're moving away from these very sequential and in stepwise workflows into this digital transformation, which is allowing for simultaneous and integrated operations. And it requires a transformation at an organizational level, but also how we operate as individuals. This massive transformation is helping us interconnect information, processes, and workflows. And it's really all about things happening at the same time, which is helping us create this smart and dynamic decision-making, and helping break down some of the barriers and help aid in collaboration. And at the center of this, is the way we see it, is really location intelligence. And that's because it helps us understand everything. Time and space are fundamental integrating capabilities. All activity occurs at a time and a place, and location provides us the framework for understanding, communicating, and providing context to our intelligence. This demand for integration is putting increased stress on geospatial professionals. And what we're seeing is organizations are quickly moving to provide tools, training, and development to make everybody in their organization be able to contribute to location intelligence as part of their daily work. And in order to make this illustration even more clear, we're going to go ahead and demonstrate to you this type of workflow of somebody capturing structured observations from imagery and contributing to a shared understanding of the battle space. And in order to do that, I'm going to turn it over to Chris Lee, who is going to take you through a SOM workflow.
Hello, good morning, afternoon, or evening, depending on where you are in the world. My name is Chris Lee, and I'm a solution engineer on the defense team based out of the Washington, D.C. office. And today I'm going to be introducing you all to Excalibur and conducting a sample SOM workflow within it, as well as explore one of our other technologies, which is ArcGIS dashboards that we can use to kind of view our analysis. So here we have ArcGIS Excalibur. It's a project-based application. Here you can see I have essentially like a web map frame with a collection of 12 images in this case, over the San Francisco and Oakland Bay Area. We also have some project layers, which are feature layers representing the 3 observations that we're going to collect in this workflow. And what we're going to do today is we're going to capture observations on moving targets within the Oakland, San Francisco Bay Area using these images that were taken different times and from different sensors. The first thing I'd like to show before we actually collect some observations is some of the exploratory capabilities that come with ArcGIS that you can do within ArcGIS Excalibur. And one of those is the use of this time slider. So through this, I can actually see which observations were taken at which time, which allows me to understand my data from a temporal standpoint. The next thing I like to do is actually explore, again, how we can keep track of the different observations that were taken. And to do so, I'm actually going to use the Flickr tool. And what this will allow me to do is I can essentially turn on 2 different imagery layers, which I've done. In this case, I have an image from September, an image from April. And what I can do is I can actually use this Flickr tool to identify which observations were taken from which image. Now that I've explored some of the capabilities within ArcGIS Excalibur, I'd like to now actually collect an observation. And to do that, I'm going to turn on what is called image space. So currently we've been operating in the map space. And this is where all the images have sort of been orthorectified and transformed so that they can be displayed on the map. However, we're actually able within ArcGIS Excalibur to view this oblique imagery, which, as you can see here in the attribute table, working with rather oblique imagery. We can actually view this imagery in its native format. And viewing the imagery in its native format will allow us to collect accurate observations, or collect accurate measurements while collecting observations. And in this case, I'd like to capture an observation on this moving ship here. And before I do so, one of the things that I'm capturing as part of my observation is the size of these ships. And so using the measurement tools within ArcGIS Excalibur, I can make accurate measurements of my observations. Collecting observations themselves is also very simple within ArcGIS Excalibur. I can simply select the observation that I'm making, place the point. In this case, we've collecting a variety of attribution with these moving ships. We're capturing their class, in this case, commercial, medium-sized boat. I can hit submit. You'll notice that, I captured the observation in the image focus panel. However, it's maintaining its geography when displaying it in the map focus panel. And that's an example of ArcGIS Excalibur really doing a lot of heavy lifting on the back end from a mathematics standpoint to kind of make those transformations. I'd like to now switch gears over to ArcGIS dashboards, which this is an application that is commonly used to take your analysis and display it in a very interactive and intuitive way for the rest of your organization, especially leaders and decision makers. And I'm actually in edit mode of this dashboard, and I kind of want to demonstrate some of the functionality that we can do within ArcGIS dashboards. And the first thing that I'd like to mention is that, or I'd like to demonstrate, is that we have the option to filter our observations from the images that were taken. We can also add these indicators as shown below the map. I have an indicator for each of the 3 observations. You'll notice as I zoom around the map, the indicators change based on the extent. So, whenever I pan or zoom somewhere, it's automatically filtering the number of features that is within the map extent. As you can see here on the left, we can also add various charts and graphs, and I'd actually like to add another chart now. Earlier when I was capturing an observation of the moving ship, we gave it a class, and I'd like to now demonstrate how easy it is to display a pie chart that can accurately reflect the a breakdown of all the moving ships by their class. So ArcGIS dashboards are not only simple to build, interactive and intuitive, they're actually also live feeds. If I return to ArcGIS Excalibur and I make another observation, in this case I would like to capture an aircraft. You'll notice that I was originally at 13 aircraft. Now as I move around, that aircraft number just jumped from 13 to 14. So together between ArcGIS and Excalibur, it makes it easy for analysts to collect observations and then relay those observations and that information to the rest of the organization. And with that, I'll hand it back over to you, Ben.
Great, thanks for that, Chris. So what you saw there was a great demonstration of that ability to capture these structured observations, and then that information can be dynamically integrated into an operational view and shared out with decision makers or other people who are working on maybe managing the collection of the project or the data, or other analysts who are working on the same problem or area. So fundamentally, data integration is a complex problem in intelligence. We have a wide variety of different source data coming from sensors and people. Being able to ingest that data into a system that provides access to everybody in a variety of applications. We need to normalize that data in terms of data structure, but also meaning, and then be able to provide analytics on that data to provide the integrated view. Fundamentally, I'd say this is the power of GIS. GIS is all about integration. It's about linking and combining information. It can dynamically link the data together through management of features and records, like you see in the structured observation use case. It can be used to visually overlay information through mashups by bringing different data layers together to be visualized in a single view. And analytics can be run across layers of data from a variety of different sources in order to detect patterns and trends. When we talk about the intelligence support for GIS, we really talk about this ability to see patterns, connections, and relationships in data. And intelligence is built through a cyclical process. That cyclical process is repeated over and over again around specific areas of focus by planning and directing intelligence collection, by doing processing and exploitation on data, doing analysis and production of intelligence products, and then disseminating that data and integrating it. And what we're seeing in this new dynamic age is that these processes are rapidly increasing, and there's more demand to share dynamically through every step in the process. And in some ways, the line between each step is blurring as we integrate tools like these analysis and exploitation tools into a dynamic workflow where we can directly disseminate and integrate that data into products and workflows. So then now we're going to get into the heart of this idea of what is structured observation management. So fundamentally, we define structured observation management as the ability to capture data in a structured form using a common data structure or ontology, which shares definition from one analyst to another or from one mission space to another. So that way the data can be combined and used and analyzed in a variety of different formats and used by a variety of different consumers. So analysts can capture this data using smart forms like we saw earlier on the Excalibur, for example, where there's drop downs and pick lists of existing structures that we've all agreed on, as well as other formats, editing tools in ArcGIS Pro, or even in forms that you run side by side with other analytic tools. We can also train AI to classify and capture data and report it and label it in using these same structures. And in both cases, that information can be fed into a common system. Speaking of AI, I want to talk a little bit about how artificial intelligence fits into the SOM workflow, but also in general, how it can be part of many steps along the way. So artificial intelligence, of course, in the computer vision case can act much like Chris, but maybe a superpowered Chris, where he's looking for ships in the ocean. Well, maybe AI can help relieve him of that burden of finding the ships, and it can identify them for him, and he can concentrate on understanding what the meaning is behind the locations of those ships or the activity. So an AI can find and use computer vision to find those objects, and it can record those as observations into a database in order to help improve our knowledge of the area. You can also take observations recorded from analysts or from machines, and it can use those to filter those in order to understand the importance of that data, in order to understand larger patterns and trends in that data, in order to do alerting on that data. And then finally, it can help us push out these key trends and identify patterns in the data in order to drive action. So you can really think of AI as existing in many different steps along the way of the intelligence process, both helping us at the computer vision stage, but also artificial intelligence and other forms of automation can help us manage and respond to observations that are being recorded by humans and machines, and also help us push out data to the right user of that data. And this is really critical because as we look at the future of intelligence, we see this real shift from this need to focus on known locations and known targets into this area of the unknown in intelligence. So we'll define this chart for you a little bit. So in general, when you're thinking about intelligence and the need to collect intelligence on your adversaries, you might know things about your adversaries, like what is their signature, what do they look like, or how are they behaving, or you might know their location. So if you know their location and you know their signature, you might just monitor the location. So an example would be a missile silo that you know where it is. In addition to that, you might not necessarily know these locations, or you may not know the signatures, in which cases you might be searching for adversaries in a broad area, or you might need to research to understand better their behaviors or signatures. And then finally, the cases where you have both of these two characteristics are unknown, you need to do discovery, and that is the realm of activity-based intelligence. So this session is not on activity-based intelligence. We have a number of recordings on activity-based intelligence on YouTube. You can also go to my website and read a lot more about how GIS supports activity-based intelligence. But I wanted to bring it up here because it's really very tightly interrelated with structured observation management. So you can think of activity-based intelligence as being the method for discovering the unknown. And then when the unknown is discovered, we now have something that we can do structured collection against. And so SOM is really about doing the structured collection that can feed back into identifying knowledge gaps or improving our knowledge of the known world. And that's really the point of SOM. We're going to come back to this topic a little bit more, but the next thing we want to do is actually talk very specifically about the software and tools that are part of ArcGIS that help support structured observation management workflows. And in order to do that, I'm going to turn this over to my colleague, Kurt, and let him take you through these capabilities of ArcGIS. Kurt, over to you.
Great, thank you, Ben. Let me go ahead and share my screen here. Okay, well, you know, what Ben said was exactly right with regards to the integration capabilities of GIS. And the science aware has been empowered by the ability to reach out and start exploiting all different sources of information coming from different sensors, whether they be drones, satellites, aerial photography. This is now a fundamental part of the ArcGIS software package, and it's exciting about where we're going with this technology. So if you look at some of the usage patterns that we're starting to support, you know, first of all, we're dealing with a large variety of different imagery from different sources. in different modalities. And so we need a management capability. And that's fundamentally at the heart of our platform. What Chris was showing in his demo was kind of a very simple application, but there was a lot of sophistication behind it to make it all work. And it all started with that imagery management. The fact is, now we can bring in imagery from all these different sources, many terabytes, petabytes of imagery, and be able to make it instantly accessible to users in thin client applications. So that's fundamentally the heart of imagery management. But we can do more than that. We can make that information that remotely sensed content geospatially very precise using photogrammetry. So taking advantage of sensor models, other sources of perhaps some ground control that you have, we can take that imagery, bring it in, make it geospatially precise, and we can even use that to extract 3D information from that using photogrammetry. So that's a fundamental capability that's now part of the platform. And as Ben was also showing and talking about, our new GeoAI capabilities. You know, imagery has always been about making observations, looking at the imagery, but we can now leverage the computer to do that in ways that are maybe much faster, quicker, and can handle and is scalable for the amount of imagery that's available if we can start leveraging GeoAI. And that is now a fundamental part of our software offerings. And then finally, even more deeper than that, we really want to start looking in those very rich, deep patterns that fall within the imagery. And so we've added a variety of raster analytics that allows the users to define fundamental workflows. Potentially, you could look at this as tradecraft and being able to do this advanced GeoInt type of work using all types of sophisticated algorithms. And so that's really where we're going from a functional standpoint on our platform. This is how it shapes up from a product standpoint, and you can see the different components that were used to actually give Chris's demo. You know, from bringing the imagery into the left, making it ortho-correct, but then sharing it out in a server-based infrastructure, whether that be cloud or on-premise, and then being able to use the Excalibur tools to exploit that. Something that's key, though, there in the middle is the work that we've done around Pro and the image analyst extension for Pro. And these are the heavy lifting tools when it comes to imagery in the ArcGIS platform. And we'll cover that more in a little bit of detail. As a matter of fact, that'll be part of the next presentation about how we use Pro to bring this all together to make it a very quick and easily solution for the vast majority of image analysts out there. But you know, before we go into Pro, though, I just want to make sure everyone is aware that we do support a large variety of different types of imagery. ArcGIS has a notion that we call known raster data types, and we're up to like 154 different known raster data types. We also include point clouds in this particular data set as well, so we can support, you know, imagery taken from LiDAR and those types of things. So it's very exciting about all the different major sensors that we're supporting in our known raster data types. And then within the community, NITF is a huge player in that. And NITF is now a fundamental capability of our imagery management. We can fully read all the NITF tags. We can leverage that. We maintain and persist all the metadata associated with those NITF images. And we have now more recently added an MSP capability. So with the Mensuration Services Protocol, we can leverage the NITF imagery to do all types of advanced mensuration, orthorectification from sources that usually get presented as NITF images. So at the heart, as I talked about, of what make this all works is our imagery management component. And there's two elements inside of imagery management that make it all work. The first of this is the Mosaic data set, and that is our data model for imagery. And it's this data model that allows the image server, which is the other component, to rapidly go in and find the pixels that someone wants to exploit and work with the data. And this is really important. We no longer need to get hung up by knowing which image file is located where. We've set up the system so that the user just goes in, draws their bounding box around their area of interest, and between the Mosaic data set in the image server, it automatically finds the pixels that analyst wants to work with and displays them on the screen so they can do their analysis. And so this is how you can very quickly go through, you know, massive archives of imagery, find the pixels that you want to work with, and be able to do your exploitation in a timely manner. We can add something more into this particular workflow, and that is the ability to add raster functions to do different types of processing. And so let me explain how that works. In the old days of working with imagery, you would have an expert who was your image analyst, and they would know the different types of things that you can do for imagery. They had the trade craft. But, you know, it took an expert, and they would go out and find the sources, and they would actually create the information products as they were requested by the consumers. But what we're talking about now is the fact that you can take different functions and you can add that to your archive of information, and the image server knows how to dynamically process that imagery on the fly. And so what you end up is with a situation where the actual consumer can go in, define their area of interest, and have the system automatically create the information products they need and have it brought back to the server. And that's how we've set up Excalibur to work. You know, we put imagery in the image server, we add raster functions to those archives of images, and then when the Excalibur brings that up to the analyst for exploitation, it has things like the lookup curves, it has the pan sharpening, it has the ortho rectification, all fundamentally in those, it's fundamentally done in the processing to bring those pixels across into the Excalibur application to be able to get the work done. So that's a key part of that image server. And that really is the ability to embed this tradecraft in the form of these raster functions to be able to do this work. So it's a very powerful solution. And Kyle, as he goes through his demo, he's actually going to show this and how this works. And this is just an example, and especially as it relates to SOM. So we have this area, it's a target area over Iran, and you bring your image in, but right now you're just using the geographic coordinates of the image and the sensor model to correct that. Well, we can look at the metadata, we can do a dynamic range adjustment to the brightness and contrast, we can fix that, but maybe we want to add some terrain in there to do an ortho rectification to make sure it's extremely accurate. That's a raster function we can add, and it's just a drag and drop function. And now what we can do is, because we've persisted the elevation data as part of that image service, when the user goes in and does their SOM exploitation, the points that they collect will have 3D coordinates. And what that means is that the next time when the analyst goes out and finds the next image, if that image was taken from a different look angle, it doesn't matter, because the SOM exploitation was done with 3D coordinates. That exploitation values will fall directly on top of that new image, even though it was taken from a totally different look angle. And so that's really how the ArcGIS imagery platform is supporting the SOM workflow. And then to show this in a little bit more detail, I'm going to turn it over to Kyle, and he'll walk you through some of the key things that allow this to happen. So Kyle, let me turn it over to you.
All right. So my point here, I'm going to try and bring some of those points home that Kurt was talking about. But I want to start off with, very quickly, in Chris's Excalibur project to set context. Excalibur really is a great tool for doing these SOM workflows, because as you can see, it's in a browser, so it's very lightweight. The interface is very easy to work with, and it gives you all the tools that you need to capture these observations. One of the reasons why Excalibur is so lightweight is because it operates off of these image services or WMS layers, so you don't have to download any of the imagery locally. You can just work with what's available to you on the server and still get all of the pixel information, all of the geographic information that you need to be able to quickly work with these images in map space and in image space. So what we're going to do is I'm going to jump into our desktop software. This is ArcGIS Pro. We have a couple of different ways that we can create image services, making that imagery accessible throughout the ArcGIS platform. There are a couple ways of doing it. Pro is honestly the best way of setting up these image services because it's the most powerful, all-inclusive piece of software that we have. So unlike Excalibur, that works solely off of image services and WMS layers, Pro can allow you to connect with your imagery in all sorts of locations. So you can connect with your imagery locally, what you have downloaded here, and you can do that by simply adding layers. You can also come to your catalog and connect your folders, everything that you want to work with locally. And by having it in the catalog, you can simply drag and drop it into your frame. You also have the ability to connect to other different storage containers. So you can use Pro to connect to different databases, all different types of servers, whether those be ArcGIS servers, WMS, WMTS servers. You can even add cloud storage connections. So, for example, we have a cloud storage connection set up with an Amazon S3 bucket. And so we can connect to our imagery directly in S3 and add it to our project without ever having to move it locally to work with it. And so there's all of our same San Francisco images that we'd had locally as well. Now, once you connect to your imagery, the best way for managing all of this imagery, especially the large collections of it, is what Kurt referred to earlier, which is the Mosaic data set. Now, the Mosaic data set, in managing imagery, and you can create Mosaic data sets in any of your geodatabases in your project. A Mosaic data set does not store the imagery. It's not a container in that regard. Instead, it's actually a pointer file. And so what you can do is when you are adding imagery or adding rasters to your Mosaic data set, it isn't actually ingesting, duplicating data. Rather, it's just pointing to wherever those files reside and making the pixels from that imagery accessible when you need them by doing that on-the-fly processing. And so when you're adding rasters to a Mosaic data set, you can pick your standard imagery type. You can also identify different raster types that will help give the best performance to the imagery that you're ingesting. So if you're working with NITF imagery, as you very likely will be doing for these types of workflows, you can add NITF raster types. You can add processing templates directly to the imagery as you're adding it to the Mosaic data set. And you don't even have to add individual files. You can simply have this tool crawl the imagery in a folder, and essentially what it's going to do is the tool will crawl this imagery folder that I have, and it will only add the NITF images within all of the folder directories into this Mosaic data set. Now, this tool takes about 2 to 3 minutes to run for this data set that I have. So I've already went ahead and created it. And the Mosaic data set not only lets you work with the images on the fly. So if we open up the attribute table here, you can see we have about 94 images in the set. So if we were to have 94 images open, it would just take too long to process all the pixels. The Mosaic data set lets you get only the pixels that you need. So not only does it do that, but the Mosaic data set allows you to view the attributes of each individual image. So it's great for cataloging functions. Now, one of the things that Kurt talked about, this is a huge advantage to working in Pro to set these up, is is working with these raster functions. These raster functions, again, when we talk about the calculations and analysis that you're running, unlike geoprocessing tools that are creating new data with every time you run an analysis on your vector data, raster analysis also works, or raster functions also work on the fly. So it's done very quickly and no data is duplicated. So what we want to do with this is we want to add elevation. So adding elevation to your layers will help increase the accuracy. If you notice here, we're in San Francisco. San Francisco has a lot of hills, and so if we're just using a constant Z when we make these collections, we want that increased accuracy that the elevation gives us. Now, there's a way that we can edit the Mosaic dataset function as a whole, and then I can go into my raster functions, drag in the geometric function, connect that, and I could run this, and I can add the DEM here, right? However, what this is going to do is it's only going to add it to this this function to the Mosaic dataset as a whole. Now, if you notice in Excalibur, we pull out individual images and work with them as we were capturing these observations. So instead of applying it to the Mosaic dataset as a whole, what I want to do is select all of the footprints in this Mosaic dataset. And now what I'll do is I'll run a batch edit of raster functions so that this way the raster function will be applied to every single image within the Mosaic dataset. And so here I can select, again, that geometric function, update it here, and I can, instead of using the constant Z, I'll use DEM. I'll use this SRTM file, which will greatly increase the accuracy. And then it just asks me if I want to run it, tells me all of the object IDs in the Mosaic dataset that it will run on. And as you can see, it goes through it very quickly on each of the different items. And now the Mosaic dataset is updated. Clear the layer. Now, to give you an idea of what exactly that does, we're going to zoom in to downtown San Francisco. And what we can do is we can compare this image here. This is a non-corrected image. And you can see the difference between the two of them, how the elevation adjusts it and makes it much more accurate. So now that our Mosaic data set is ready for SOM analysis, what we can do from Pro, we are connected to our ArcGIS enterprise. This is the same enterprise that we were working with in Excalibur. This is where our image server is located. And so what we can do is we can share this Mosaic data set as a web layer. And so it's a simple matter of just giving it tags, the summary. You do need to either register the reference the registered data or copy the data up to the portal. If you're working with imagery locally, you'll need to manually move the imagery up there. However, if you were working with imagery in S3, other cloud environments, other different databases, you can simply register reference the registered data as long as those cloud stores are also connected to your ArcGIS enterprise as raster stores. And so once that's shared as a web layer, then it becomes accessible in your portal. Not only as you saw it there in Excalibur, but you can bring that layer into Pro as well. And so we can turn this Esri layer on. And if I open up the properties, you'll be able to see the source of this layer that it's connecting to the image server itself. So there you can see that it's connecting to the REST endpoint rather than a local image. And we can work with this image service just like we do with the local imagery. One last thing that I want to show, though, just to highlight the interconnectivity. Pro is great for all of this heavy lifting, but it also does the simple stuff too. So that moving ship layer that we were working with in Excalibur, that is that's a feature layer, a hosted feature layer, and we're able to bring it into Pro and work with it here as well. And so what I can do, I can also work with these images in image service, or work with this layer in image space in Pro. And while it's not as simple as an interface as an Excalibur, I do have the ability to create different features and update the attributes here directly in Pro as well. The advantage to working with this in Pro is that you have the ability to work with different analysis tools, so we could run different types of analysis on these points, like finding hotspots, calculating density, etc. of all of these features that we've captured. We have access to the whole suite of analysis tools here in Pro. So with that, I'm going to turn it back over to Ben.
Great, thanks a lot for that, Kyle. That was really great to dive in deep into how we configure and provide out services as a way to make the imagery that we're using for our structured observation management accessible, accurate, precise. We saw we can have functions and processing on that imagery to make it easier to use and ready to use for this type of analysis, and to make services. And so the key about that is those services can be used anywhere in any of the clients, any of the applications across ArcGIS, but also by others. It's an open platform that can be used by a variety of different systems as well. Anybody that has a standards-based approach to working with geographic information. So, and I'm going to dive into a little bit more about kind of principles around structured observation management as we started earlier. So we talk about different kinds of intelligence. Structured observation management can actually support a wide variety of different types of intelligence. It can help us with strategic intelligence by helping us understand and do better estimates on our adversary, for example. It can help us with current intelligence and can be in products like the President's Daily Brief with things like indications and warnings and day-to-day intelligence. It can be used to produce data that can help us support basic intelligence, like understanding factories and production output and other things like that of countries or nations or specific capabilities. And as I mentioned already, it can help us with discovery intelligence by being that strong connection between discovery and the known universe. When we talk about this traditional intelligence and discovery intelligence, the kinds of things you're going to be looking for are going to be different in the different scenarios. So in traditional intelligence, you might be looking for these very durable or physical signatures of an adversary, so a missile silo at anti-aircraft gun, where the signatures in a discovery case might be changing constantly, and so you actually need to adapt your model. So an example, in early days of Operation Iraqi Freedom would have been, oh, now we actually want to see where white Toyota pickup trucks are, or something like that, right? So the type of thing we're looking for is different. The size of the unit we're looking for is often different in this new world. We're often looking for individuals or specifically tight observations, where in the traditional intel, we're looking at larger things. And I think some of the things that are really important is as we start to think about the frequency of collection and the types of things we're looking for, it starts to become much more dynamic and much more real time. And so coming back to this idea of the relationship between ABI and SOM, as we identify the kinds of things we want to collect using our ABI workflows, we want to go out and use a structured process to capture our observations related to that. So for example, we might determine back to the white Toyota case, that we decide that people driving vehicles around in the middle of nowhere are something we want to look for. We don't know where they're going to be driving, but we know they're out there somewhere, and we need to look for them. And when we look for them, we need to capture what they're doing, what their activities are, and in what ways they're operating. And that's really how these two things relate together. And this is really, we're going to dive into our kind of next major area of SOM, and that's around the areas of motion imagery, and even still imagery can play into this. And the idea here is what we're talking about is the idea of capturing activity. So not just the existence of an object at a location, but also the activity of what's happening at that location. And often motion imagery is a key element here, because it's the best way to observe short duration activity. So imagery can be useful for long duration activity like ships in a port or cars in a parking lot, things that stay in place for a long period of time. But motion imagery is really about all the other activity that we all experience all the time in our lives, which is that rapid activity. And we can, of course, apply AI here, but we can also do manual analysis or interpreted analysis on imagery as well. And to get us into that, actually, we're going to ask Kyle to give us one last demo around motion imagery.
All right. So yeah, I'm going to show a very quick demo to end out here. This is on our full motion video capability. This is something that is also available in ArcGIS Pro. What it allows you to do is it allows you to connect with video data that is what we refer to as MISB compliant. So that refers to a certain set of geographic standards in the metadata that allows us to project this this video data onto a map. And so as you can see, I'm going to go ahead and dock this video window right here. As we have this video play, in this 3D scene that we have here, we can see the position of the sensor, its flight path, we can see its line of sight, and we can see its field of view. And so this tool, the video player, gives you many different standard video playing tools, pausing, fast forward, being able to scroll ahead, jump ahead to different parts of the video. But it also gives us a lot of different tools that are very helpful in SOM workflows. So one of the tools that we'll show, or one of the abilities that we'll show just to start here, is the ability to use your feature services or your feature classes in Pro and use them to edit what you see in the video and have it appear in the map. I'll give it just a second here.
If you'd prefer, Kyle, I can come back to you if you want to try to troubleshoot that, and we can come back and do it again. Yeah,
let's try and troubleshoot this. I apologize.
Sure, no problem. We'll just keep on moving. We're getting close to the end anyway, so we'll close. Let me know at the end if you're able to do that, and we'll come right back to it. So I think the point we were going to show there, we got to see the motion imagery, which is the most exciting part. Of course, you've all seen us drop dots on imagery, and that's exactly what Kyle is going to do, is drop a dot on the motion imagery, just like we were doing on still imagery. And it's really fundamentally the same concept from there, which is pretty great. And so really what we're going to then talk about is this idea of essentially it's getting information from data, right? So we've talked a lot about still imagery and motion imagery. So you can get certain types of data from imagery, so buildings, roads, features, vehicles. You can get, for motion imagery, you can get things like tracks and human activity. Other kinds of imagery can give us things like materials and warm objects, operating equipment, et cetera. But we can actually also get structured data out of other data sets like textual reports and financial transactions. And in all these cases, what we're thinking of in many cases is this observation, this like discrete bit of data. But we also want to do quite frequently is not just take that discrete bit of data, we want to understand it in the context of what's happening around it. So we might want the individual activity to be captured, but we also want to compare that to context. We understand what's the typical patterns in that area, for example. We also might want to integrate in biographical information around a specific entity or relational information describing relationships. And one way to do that is to link data through databases and identifying values, which is one way we can do that. The other way is to do what we call geo-enrichment. So based on the location of a piece of data, we can compare it with and combine it with and enrich it with other data. So for example, you might want to know what is the demographic makeup or the tribal boundaries or the political boundaries for this observation? What is that typical pattern or trend in the data? And we can do that by just combining the location of the observation along with this reference and contextual data. And that also applies as we start to think about taking in other data from other sources beyond imagery. So as we think about integrating in observations and recordings from natural language processing, so from textual data sources, whether that's structured reporting that we might use using a tool called LocateXT that takes location out of a structured report that's but it's not in a geospatial or a database format. We can find locations in that data and make structured location-aware data. We can also use natural language processing tools that are found in AI to find entities and locations and create relationships that way. So we can bring in observational data both from humans observing on imagery or from humans running processes on semi-structured data, or even from natural language processes that run on unstructured data. And ultimately, we bring that all together into this common structure. And that structure is stored inside of a data store in ArcGIS, which can be a variety of different kinds of databases. And then it's provided out as services, which are standard open services called feature services. They can be integrated into a variety of applications. So you think of this as a standard way to record information, but also it provides an interface that is standardized that we can use to push out these observations and records out to a broader audience. So that's going to conclude our structured observation management workshop. I'm going to give Kyle a second to see if he's able to show us the rest of that motion imagery. While he's doing that, if he can, you guys can think about questions you have and ask them in the questions module. Kyle, are you going to be able to
I am ready to go.
Awesome, perfect.
Ready to go.
It
must have just been a 1 in 100.
It's 2020, man. We're at
That's
least
right.
All right.
But we're good to go now. So again, we've got a car follow here, and so I've got my feature layer here that I can drop dots onto the video, and now you can see it's working very smoothly. But I can drop points, breadcrumbs on this car as it follows, and you can see in the map here that it has adjusted, or that it has placed those features where they correspond. And like any SOM workflow, I have the ability here to update the attributes here. So I can type out comments, I can type suspicious vehicle, and if we zoom in to the video here, I can see that it's a white pickup, so we can add that. And I can even get some measurements on the truck if I wanted to add that as well, get the length of it, change it from meters to feet. We can add that as well. 25 feet. So very easy to integrate these types of traditional SOM workflows directly into in this. The other thing that I wanted to show actually was the ability to take a frame capture and add that directly to the map. So what I can do with a single click, I'll move it onto the bridge here. This is a good spot. When I move it onto the bridge here, in a single click, I can take the current video frame, save it as a single image, and it's going to automatically orthorectify that onto the map where it's supposed to go. So you can work with these single imagery layers. Another thing that you can do, instead of just clicking one image at a time and adding that to your current map, you can save multiple frames to images as you're playing the video. So this allows you to select the format that you want it saved in, add the frequency in which you want these frames to be captured. So we can have it save a frame every 4 seconds, or we can save it by the frame number themselves. You now have the option actually to add these images directly to a Mosaic data set. And you can select here what Mosaic data set you want them added to. So we could add them to this one if we wanted to. I already have the Mosaic data set set up for this portion of the demo, but so as we have this selected and as we play the video, it's automatically saving these images to a folder. And so you can see the images saving here as the video plays. And as I said, you can have these images saved directly into a Mosaic data set. So this shows, this is an area where where I collected the frames earlier. And if we turn on the layer, you'll be able to see all of those footprints that were captured. And so now what we can do with this Mosaic data set is we can take this workflow and take it back up to Excalibur. Just like we showed earlier, I can share this as an image service, and then people can do the SOM workflows up in that lightweight environment as well. So I think that's about all the time that we have, so I'm going to turn it back over to Ben to finish it out.
Yeah, great. Thanks a lot, Kyle. That was perfect. I'm glad we were able to see the full set of capabilities there. So I will go ahead and take over and close us out and just basically answer a couple questions as we're getting close to the end of the time here. So again, feel free to ask some more questions in the window. If nothing else, it'll help give us ideas of things we could answer in the future, or maybe reach out to you directly. So one of the questions that came in early in the presentation that I did want to address was actually from Molly Ross, and she asked, can you discuss the back end? Is this a feature service into Elastic or ? And I think it's a great question. We did spend a lot of time on the back end of imagery, but we didn't actually spend a lot of time on the back end of the observations that are being recorded. So I just want to answer this question briefly. This is actually a topic we cover in many other sessions as well. So basically what I would just point you to is these observations are all recorded as what are called features. And features are stored inside of a feature service. A feature service behind it has a database, and there's a lot of different databases that we can use behind feature services. If you want to look into ArcGIS Enterprise is how you would do that on your own networks with your own databases, or if you're using ArcGIS Online, all of that is basically hidden from you. You just work with the feature service directly. The main power of that is a feature service provides us a structured way to capture data, and it provides us templates that we can use to make it really easy to quickly capture features. So behind the scenes in Excalibur or in ArcGIS Pro, attributes are being populated. There's a lot of values that are getting captured. Like in Excalibur, for example, it's automatically capturing information about the imagery that you're collecting the data from, etc. So there's actually a lot of rich data being captured all the time in all these different applications. And that's also getting stored in the database. And that's pretty useful later on when you're trying to do analysis or share the data with stakeholders. So I just wanted to address that specific question.
Hey, one more thing to add.
Sure, go ahead.
One more thing to add to that, Ben, too, is if you don't have an existing template, for your feature service, Excalibur allows you to actually create one. And so you can actually add your own fields and whatever you want to collect right inside of Excalibur, which is kind of a pretty powerful capability for a thin client application like that.
Yeah, so then what's pretty great about that, thanks for pointing that out, is that you can basically start with nothing besides some imagery and get rocking and rolling with capturing observations with essentially nobody else. You can do it all by yourself and get up and running real quick in a web browser with no administrator or anybody has to step in for you. So that's super useful, great. I think a couple other questions here really kind of related to where can I use this? Where can I have access to this? So generally speaking, if you're running on some secure networks, there are a lot of these capabilities available on those networks. If you want to know more about that, just ask for us to contact you. And when you close out of the webinar, there's a little opportunity to say you want to be contacted by Esri, and we'll get you in contact with your account manager that services your specific agency, and they can point you at resources for getting access to some of these tools. Excalibur that you've seen a lot of today is a product that is something you add to your enterprise and that you use with to add to your enterprise. So if you already have ArcGIS Enterprise, and you already have image server and image services, then you need to bring in Excalibur and add that to your enterprise. So again, if you're more interested in that, please let us know, and we'd love to get you connected with the right people to tell you what you need to do to get up and running. If you've never used ArcGIS before, we'd love to also help you with that. Yeah, Kurt, you wanted to add?
Yeah, and the one question there from Max, one of the things that we're going to be releasing here very shortly is a image server capability for ArcGIS Online. So right now, when you run Excalibur, it does require an image server enterprise and getting that all set up. But in the future, we're going to actually have an image server capability in ArcGIS Online, so users can actually just push their imagery into ArcGIS Online. It'll create the image service, and then you can hang an Excalibur application off of that. So I just wanted to point that out, Ben. That'll be out before the end of the year.
Great. Yeah, thanks a lot. Yeah, thanks for bringing that up. That is pretty darn exciting, actually, as well. So that'll be great when we have that capability available. All right, I think with that, we're going to go ahead and wrap it up. I really appreciate a pretty lively set of questions from the audience and a great attendance overall. If you enjoyed the session, I recommend registering for additional sessions. We have some more imagery related sessions coming up even as soon as next week, and then some others around things like infographics and actually GeoAI, which we talked about quite a bit today, and which of course we'll touch on imagery and facility management. So just revisit the National Government Webinars webpage to sign up for those upcoming webinars. And we're adding webinars all the time, basically as long as we stay in this COVID situation, we'll keep adding webinars every 2 weeks, same kind of bat time, same bat channel, and we look forward to seeing you again in the future. So thank you very much, and have a good rest of your day.